So what going everybody, and welcome back to Jumanji. So let's piggyback off yesterday's lesson and continue talking about aromatics. So if you know the rules for determining aromatic compounds but still having trouble applying them, then this lesson is for you, right? So one of the first rules says the compound needs to be cyclic, aka a closed ring structure. The next rule says your compound also needs to be planar. It needs to have empty 2p orbital because you need a continuous loop of overlapping p orbitals, aka a localized pi system, right? So that's just saying no sp3 hybridized orbital welcome, which makes sense. If you need an overlapping p orbitals, you need an empty orbital or orbital with room to overlap, right? Now the next rule says it needs to meet the Huckel rule or Huckel number that says it needs to have 4n plus 2 pi electron count. That's just a fancy way of saying when you count up the atoms involved in this aromatic system and in the double bonds and the lone pairs involved in the system, those numbers, the electron count needs to equal 2, 6, 10, 14, 18, and so forth. So we're counting by 4 after we leave 2. If all those are met, then the compound is considered aromatic, right? So let's apply those to these compounds. So the compound first needs to be cyclic, check. It needs to be planar, right? So no sp3 hybridized orbital welcome. We need that empty 2p orbital. So first we need to know that an oxygen that has 2 lone pairs, 2 sigma bonds or 2 single bond is sp3 hybridized. Based on that alone, we can rule out this compound. But let's say that we can promote 2 of these electrons into the system that we want to make aromatic, right? So if we do that, it now becomes planar because these are already sp2 hybridized, and now this is, right? So now it's planar. So let's see if we meet the Huckel number. 1, 2, 3, 4, 5, 6, and those 2 electrons that we promoted, 7, 8. 8 is not one of the Huckel numbers, right? Remember, we're counting by 4 after we leave 2. So 2, 6, 10, 14, 18, etc. Right? So and that reason alone is also not aromatic, right? But if we didn't put that lone pair in, we had 1, 2, 3, 4, 5, 6, then it would have met the Huckel number, but it wouldn't have been planar. So for those reasons, this compound is not aromatic. Now let's apply those same rules to this compound. Right away we see an sp3 hybridized oxygen here, right? We also have 1, 2, 3, 4. So based on those 2, we can rule it out as aromatic. But let's say we can promote, like we did here, a pair of electrons into the system we want to make aromatic. Now we have 1, 2, 3, 4, 5, 6, right? So not only did we convert this sp3 to an sp2 oxygen, we also met our Huckel number, went from 4 to 6. So that is why this compound is aromatic, and this is why the compound also behaves the way it does, right? Because at the end of the day, right down to our atoms and compounds, we all want stability, right? So if we can achieve stability by promoting these electrons, why not? That's what it did, right? This guy figured out no matter what I do, if I promote it, if I do or don't, I'm not going to be aromatic anyway, so why bother, right?